Hi guys! Let's continue to talk the 18 biggest unsolved mysteries in physics. If you missed the first part, click here. Don't forget to subscribe my channel, put your thumb up and click the button of the bell to get all my notifications. Okay, let's continue. Particle collapse. Particle collapse. Each particle is described by a wave function or probability distribution, which tells what its location, velocity, and other properties are more likely to be, but not what those properties are. The particle actually has a range of values for all the properties. Until you experimentally measure one of them, its location for example, at which point the particle's wave function collapses and it adopts just one location. But why and how does measuring a particle make its wave function collapse, producing the concrete reality that we perceive to exist? String theory. String theory. String theory allows physicists to reconcile the laws governing particles, called quantum mechanics, with the laws governing space-time, called general relativity, and to unify the four fundamental forces of nature into a single framework. But the problem is, string theory can only work in a universe with 10 or 11 dimensions. 3 large spatial ones, 6 or 7 compacted spatial ones, and a time dimension. There's not conceivable way to detect anything that small, and so there's no known way to experimentally validate or invalidate string theory. Order in chaos. Order in chaos. Physicists can't exactly solve the set of equations that describes the behavior of fluids, from water to air to all other liquids and gases. As a consequence, the nature of chaos is not well understood. Physicists and mathematicians wonder if the weather merely difficult to predict or inherently unpredictable. Does turbulence transcend mathematical description, or does it all make sense when you tackle it with the right math? Forces. Forces. The universe experiences 4 fundamental forces: electromagnetism, the strong nuclear force, the weak interaction, gravity. To date, physicists, if you turn up the energy enough, 3 of those forces unify and become a single force. Physicists have run particle accelerators and unified the electromagnetic force and the weak interactions. So far, no particle accelerator has reached energies high enough to unify the strong force with electromagnetism and the weak interaction. Besides, the issue of energies, called grand unified theory, still have some problems because they predict other observations that so far haven't planned out. Black hole. Black hole. What happens to an object's information if it gets sucked into a black hole? According to the current theories, if you were to drop a cube of iron into a black hole, there would be no way to retrieve any of that information. That's because a black hole's gravity is so strong that Its escape velocity is faster than light. However, a branch of science called quantum mechanics says that quantum informations can't be destroyed. So, what's the truth? Will we find out sooner or later? Singularities. Singularities. A singularity occurs when some property of a thing is infinite, and so the laws of physics, as we know them, break down. At the center of black holes lies a point, a singularity, that is infinitely dense. In mathematics, singularities come up all the times. Dividing by zero is one instance, and a vertical line on a coordinate plane has an infinite slope. But what would a singularity look like? How would it interact with the rest of the universe? Okay guys, let's continue the next Friday for the part number 3.